Hello friends and welcome at my channel. Last time we showed the nice limit of x minus sine of x divided by x cubed, which was equal to 1 divided by 6. Today we go further and I would like to show you a combination of different limits, and we're producing a new one which is really looking crazy, but well, you see how we can compute it. The thing is, we're starting with limit x towards 0 and we're just rewriting it as 1 minus x plus sine of x to the power of 1 divided by x cubed. Now we can write it as limit x towards 0, and now we're having 1 minus, or let's say maybe plus sine of x minus x in parentheses, and then we multiply it times, now look, we have 1 divided by x cubed still, and we are just writing, we are multiplying it times 1, which we are rewriting as sine of x minus x divided over sine of x minus x. Everything is fine, right? So now we are writing it as limit x towards 0, 1 plus, then we have sine of x minus x to the power of 1 divided over sine of x minus x times sine of x minus x divided over x cubed. Is that okay? I'm just using the commutative law for the multiplication. And now if you look carefully, you'll see that we've done limit n towards infinity. I link it here. 1 plus 1 divided by n to the power of n was equal to e. So let's see what's happening here, all right? So we'll see in a moment what's happening, but let us write it down this way. This is a limit x towards 0, 1 plus sine of x minus x to the power of 1 divided over sine of x minus x, and then we have the total expression to the power of sine of x minus x divided by x cubed. I'm just only applying the common power rules. So what is happening here? Let us call y as sine of x minus x. So since x is approaching 0, y is also approaching 0. So what do we have out of the limit x towards 0, 1 plus sine of x minus x to the power of 1 divided over sine of x minus x. Let's take this one outside for a second. So what we have with this substitution is a limit y approaching 0. Then we have 1 plus y to the power of 1 divided by y, right? And for the sake of argument, let us say this is a positive value. Well, we don't actually care about this value, whether it's positive or negative, because it's symmetric. So let's say we're running from the, so for limit to exist, it doesn't matter whether we're running from the right-hand side or from the left-hand side. It should be equal in both cases. So we assume we're just taking the right-hand side, and the left-hand side must be exactly the same, all right? Otherwise, the limit wouldn't be existing. So if that's the case, let us call n to be 1 divided by y. Y is equal to 1 divided by n, and n is running towards plus infinity, since we are talking about y approaching 0 from the right-hand side. So that means we're having a limit n towards infinity. We're having 1 plus 1 divided by n to the power of n. So this is e. So this huge expression is becoming e, and we only have to figure out what is the sine of x minus x divided over x cubed. But you see what's happening here. We've done it previously. This is almost the same. We just have to change the order of the values in the numerator. So we just have to take a minus in front. So if we're having a minus here, in order to make minus x plus sine, which we're having here, we also should change it to minus 1 divided by 6. So that means this whole expression is becoming to e to the power of minus 1 divided by 6. This is 1 divided over the 6th root out of the Euler's number. Isn't that crazy? I think it's wonderful. Thanks for watching. See you guys in the next video. All the best. Bye-bye.